In cooking process of patty using air fryer, heat is distributed equally in the air fryer to each part of the patty. So, do you know that why is it important to ensure equally heat distribution in an air fryer? The answer is to ensure even cooking. If food is overcooked, it will be bad taste and texture, and the nutrient of the food will be lost. Besides that, formation of harmful compound in the food will also increase in the cancer risk. If a food is undercooked, it will increase the food safety risk because of the harmful bacteria in the food, and the food will also taste like cold and chewy.
Okay, from the simulation just now, we can see how the heat spread through family patty during the air frying. So at start, the patty was cooled, so which is a typical for frozen food. Okay, and then as the air fryer hits the surface, we can see the temperature begin to rise at the outer edges first. So by over time, heat begins to move inward, gradually moving up the internal layers. This process was called thermal conductions. Okay, and then the heat equation models the exact behavior where temperature change over time is driven by the temperature difference between neighboring points. So we can notice just now the center of the patty remains cooler for a longer period. This is because heat has to travel from the outside in and it takes time to cook. So when the core temperature increase, it's showing the patty is approaching a fully cooked.
Assalamualaikum and a very good day. I am Wanur Amina Shwada and I will be presenting the introduction of PDE. What is PDE? PDE is a partial differential equation. It describes how things will change over time and also space. It is used to model heat, waves, fluid flow and also summer. As in our case, how heat spreads inside patty. To relate with real life situation, firstly the patty is placed in hot air fryer and then the hot air will heat up outside first and after several times the heat will move inward to warm into the center of the patty. And for the equation given will be dt over dt equals to alpha nabla squared t. T will be representing temperature inside the patty. Dt over dt will show how fast temperature rises at a point. Nabla squared t represents how uneven the heat is around that point. And lastly, alpha is how quickly the patty conducts heat, which is depend on fat, water, and etc. That's all from me. Thank you.
Hi everyone, I'm Afina. Now I will explain the importance of initial and boundary condition in solving the heat equation using a patty in an air fryer as our example. First, the initial condition tells us the temperature inside the patty before heating starts. In real life, this would be patty just taken out from the fridge, evenly cold around 4 degrees C. Next, the boundary conditions describe how heat enters from the surface. In an air fryer, hot air at 100 degrees C hits the patty from the outside first. These two conditions are crucial because they define how the heat equations start and behave. Without them, we can solve the PDE properly. Now let's look at the simulation result that shows how temperature changes inside the patty over time. At t equal to 0, the whole patty is blue, meaning it's still cold just like when we first take it out from the fridge. This reflects the initial condition. At t equal to 120 and 300 seconds, we start to see the outer layer heating up. This is because of the convection from the hot air hitting the surface. That's our boundary condition at work. Even at t equal to 600 seconds, the center is still cooler. That's because heat takes time to conduct inward from the surface. This proves that heat doesn't instantly spread inside, and it's explains why undercooking can happen if we don't give enough time. Thank you.
Good morning everyone. Today I'll be explaining about applications of PDE. The first one is an accurate modeling of temperature change, which means it describes how heat moves through matters like solid, liquid or gases over time, and it also captures both time and space variation. Moving forward, the next application is applicable to complex shapes and materials. It also can be applied to various geometrics like roads, slabs and cylindrical patties. It also works with the real life materials such as meat, dough and metal. And the next application is it can be customizable for real conditions. For example, it can adapt itself to convection, conduction and insulation scenarios, and also incorporates boundaries, for example oven heat, and also initialize for example frozen conditions. And the last but not least, PD also improves process efficiency and safety. As I said, it helps to reduce guesswork in design and food processing. Also assists in avoid undercooking or overheating. Especially is essential in safety critical foods. That's it. Thank you.
To conclude, partial differential equations or PDEs play a crucial role in science and engineering because they help us model how things change over both time and space. In our project, we use the heat equation to show how heat spreads inside a patty during the air frying process. This is important because it helps us ensure the patty cooks evenly, which improves food safety and quality. More broadly, PDEs are used in many real-world applications like understanding heat transfers, fluid flow, and much more. They are powerful tools that help engineers and scientists solve complex problems efficiently.